Carbon Sequestration by Group 29. There are four main factors in the consideration of our design. Cost, the amount of money, resources, time, and energy required to create and run. Safety, consideration of the consequential impacts on people and the environment. Efficiency, achieving maximum productivity and minimizing wasted efforts. And physical design, likely to succeed or be effective in real circumstances, physically feasible.
Here in my design, which appears to be a silo, there will be multiple platforms to allow the maximum amount of plants to grow. In the drawing, the green dots represent the plants. The blue at the top is a blue filter for sunlight because plants grow faster in blue light, along with many mirrors and some artificial light to encourage plant growth. Underneath is a main water line that has a propeller that rotates when water passes and allows energy to be created to power the fans that allow better ventilation and to cycle out the air. The things sticking out on the sides are vents to allow the air to escape. And to water the plants, there are sprinklers over each platform of plants.
My individual design is a controlled peat bog carbon sink. Peat bogs are one of the most efficient natural carbon sinks found on Earth. In Figure 1, a wind turbine powers the rotary chambers and allows for 360 degrees of air intake coverage. Carbon dioxide is filtered out in the thermal chambers and the rest of the air is allowed to flow out. In Figure 2, this carbon dioxide is sucked into the artificial biome. Temperature, water flow, lighting, and air pressure are just some of the variables maintained to suit the peat bog.
In my design, where the green ovals represent all kinds of plants, the glass roof doors open up to let in rain to save on water, but there are backup sprinklers just in case. Pipes on each floor help drain excess water down to lower floors to keep the soil moist. There's a propeller that generates energy to turn on sprinklers and regulate air control. Lights are pointed towards the lower floors, which have plants that need less light than the ones higher up. A vacuum pumps in carbon dioxide to be filtered.
This is my idea. I plan to have a facility made from strong, resistant glass that should hold up to strong weather and allow sunlight to enter. Under this facility, there's an underground storage built in with a regulator that would control how much carbon goes inside the facility. There's also a water mill that would help move water into the indoor sprinklers that would water the plants.
We have our evaluation matrix with our criteria: cost for weight of 9, safety for a weight of 7, efficiency for a weight of 10, physical design for the weight of 2. For Bernard's design, we gave it a 9 for cost, 7 for safety, 8 for efficiency, 7 for physical design with a total of 224. For Martin's design, we gave it an 8 for cost, 7 for safety, 8 for efficiency, and 9 for a physical design with a total of 219. Nadav's design, we gave it 8 for cost, 9 for safety, 9 for efficiency, 7 for physical design with a total of 239. Alex's design, we gave it a 10 for cost, 8 for safety, 8 for efficiency, and 7 for physical design with a total of 240.